Okay, this video is for 12.1G, volume of prisms and cylinders. So, last week we started talking about area of different shapes, and then we're going to move that discussion this week from area to volume, and they do relate a little bit to each other, and that is through the formulas. So let's start with problem 1 and 2 and make sure that we know the formulas and how to find the volume of the different shapes that we want to find. So, volume for the formula for the volume of a prism is real simple. Essentially, it's just the area of the base times the height of the shape. Remember, capital B is the area of the base. So if it's a triangle base, you do the area of a triangle. If it's a circle, you do the area of a circle. Square, area of the square, and then you multiply it by the height of the shape. Now, the formula for the volume of a cylinder is basically the same thing, we just write it a little different. We said that the volume of a cylinder is pi r squared times height. But remember, a cylinder has a circle as its base, and pi r squared is the area of a circle, so this is also the area of the base. So basically in all these problems, what we want to do is identify what is the base, find the area of it, and then multiply by the height of the shape. Because finding the base is so important, let's make sure that we know what to look for when finding the base. So in problem 4, it's asking what's the base of this shape. And this would be the base right here. You can see it has 6 sides, so that is a hexagon. Oops. Same in number 5. The area of base is going to be the shape here, the triangle. And in 6, you can see it's a rectangle. Alright, now let's do a couple where we're actually finding area. Now in 10, you can see this shape right here looks like a trapezoid, and we know it is because they've also given us these markings here that show us that the two bases are parallel to each other. So this is a trapezoid. So what we want to do is find the area of the trapezoid and then multiply it by the length or by its height, and its height is this number right here, which is 10. So we discussed last week that the area of a trapezoid, or in this case big B, the area of the base, is 1/2 times the height times base 1 plus base 2. We can see, now let's look for the height first. The height is this vertical distance right here, which they say is 5.2. And base 1 and 2, one of them 6 centimeters, and you can see that the other is 12. They've written 12 on that back base, but the back base has to be the same length as the front, so we know that the front is 12 as well. So we have all the information we need to figure out the area of the base, so let's do it. So the base equals 1/2 times the height, which is 5.2, times base 1, which is 6, plus base 2, which is 12. And if I'm going to throw this into my calculator, I'm going to use 0.5 instead of 1/2. Multiply that by 5.2, and then 6 plus 12 is 18. So if I type these three numbers into my calculator and multiply them all together, I will get what the area of the base is. And what we get when we do that is 46.8 centimeters squared. Alright, so we found the area of the base, which is big B, but remember what our equation is. It's the area of the base times the height of the object. So now we need to find the height of the object, which we already said is 10 centimeters. So now we got to take the area of the base, or big B, 46.8, and multiply it by 10. So volume is going to equal 46.8 times 10, which is pretty easy. That is just 468. And this time we have cubic units. So it was centimeters, so now we have cubic centimeters. And that is our final answer. Now let's flip to the bin with a cylinder. So remember, the volume of a cylinder is pi r squared, which is the area of the base because it's a circle, and then times height again. So we can throw every number straight in to this formula. Here's our r, here's our h, so let's plug it in. So volume is going to equal pi times 6 squared times 12. Throw that into your calculator, you get 1,357.17 kilometers cubed. And that's our final answer.